The first challenge was Babyseek. I'm a little bit surprised I got first blood, but I'll take it. It says, I'll let you seek around the file as far as you want, but you can't go anywhere since it's dev null. To figure out where things are, you can use the GDB debugger. I recommend using Docker. And something about the GOT and how to print out entries. So we're given some files and a netcat. If we look at the files, we're given a C file, always appreciated, the binary, a way to build the binary, I would guess, and a Docker file. So I already have these open. Let's take a look here. Here's the C file. At first, I was very excited for this challenge. I know there's a concept called file system wrapping, which I've never actually done. I've only seen write-ups for, so I figured this was my chance to do something with file system pointers, since it's kind of a black magic to me. Thankfully, this was a very nice intro challenge to kind of learn about the file structure, the file object structure. So anyways, we have a win function. It's just going to print out our flag, so we have some sort of ret to win. The main function will do some buffering. It'll leak out the address of win. Then it's going to open a file, so we have a file pointer here. It'll open to dev null in write mode. We have some position variable. It's going to set our win address to something called super special, which we can see is used at the bottom. It's then going to write the string void 1 byte at a time for 4 bytes into the null file. Then it's going to say I'm currently at, and it's going to leak this value. So we need to look up what this is. So in the null file structure, or the null file object, there is a member variable called IO write pointer. And so they're going to leak that to us. Then it's going to printf, then it's going to read an integer, and then it's going to increment this pointer by whatever number we give it. Then it's going to take the variable that was set to the win address, and it's going to write it into the null buffer, or sorry, into the null file, and then exit. So based off the hints they were given, they said something about the GOT, so we're probably going to overwrite the global offset table, and if we do that, we can have it on exit, or let's see, yeah, it'll have to be on exit, so we can overwrite the existing entry for exit, and instead put our win address. So if we take a look, first let's do checksec, make sure we're actually able to do that. We can see that there is no rel row, so we are able to overwrite entries. And we can see there's no canary. We're not doing a buffer overflow, so that doesn't matter. We don't really care about non-executable stack. Pi is enabled, but thankfully they gave us info leaks, so we know the addresses of stuff we need, and nothing else really matters. So really the only thing we need to do is figure out what this IO write pointer is. So I googled around a little bit to see what this was, and I think this was probably, yeah. So we are given IO write pointer, so this is the current put pointer, and it's next to a base and a end pointer. So it looks like in the file structure there's some sort of buffer, and maybe contents are written to that buffer. We can actually take a look and see what that looks like. So if we run gdb chow, let's do start, next. So you can see we're down here, so we're in int main, we're doing the buffering, printf, our flag is located. Null, so we opened up a file, so we can now look at null. We have this down here at the bottom, so null is a file pointer. We can view its contents by doing dereferencing it. So right now it doesn't look like anything is set up within the null pointer. Here is our write pointer, the one we're eventually going to get the address to. So I guess they have to do this write first so that the write pointer is initialized. Anyways, we'll continue next. So now we're setting the win address. Now we're about to do the write void. So if we look at the file pointer now, cool, we can see that these pointers have been set up. So we have a write base, which is pointing to this address, which has the string void. Then we have our current buffer, our current pointer, the one that's going to be leaked. We can see that it is 4 bytes above the start. So it wrote out void, and now we have the address right after that. And we have a end. So it looks like, I guess when a file object is set up, it allocates a couple buffers. We can see that this buffer size goes from 9480 to A480, so I don't know how many bytes that's up, maybe a full page of memory for this buffer. Cool, so ideally it seems like this gives us an arbitrary write. So we could set this to the value in the global offset table, and then it would write our win address to that value. And so we can take a look at the global offset table. We can see we have a couple different functions. The write happens near the end of the file, and so the only function we can really overwrite is the exit function. But if we can overwrite this with our win address, we would win. So this is the address of exit, and right now it's pointed to this, but instead we're going to point it to win. Cool. So what we'll have to do then is we'll need to calculate two different offsets. First, we're going to have to figure out the address of exit. Thankfully, we're given a libc leak, so I'm pretty sure we can easily... Sorry, actually, we don't need that. We have the address of win, which is in the main elf section. And so from that, we can calculate the offset of exit. And then we can calculate the difference between where this is currently located and where this address is. Cool. So if we look at the solution file, so just using pwn, and this is just some setup. I turn off the bytes warning. We load the binary. We turn debug on, tmux. We're going to read until it says around. Then we're going to parse out the win address. Let's run the binary real quick. So we can see first we're going to get where the flag is located. So this is the write-to-win function. Then it's going to read until at. It's going to give us the address of the null pointer. So from there we can calculate the exit address by just subtracting values. And I just do this from one instance. I get the address, and then I print it out here, and then I just subtract the two, so I can easily calculate that. Then we can calculate the seek length. So if we remember from the file, it's going to append the position. So seek length is where we want to overwrite this to. And then from there, I print out all the values just to make sure everything lines up. And I've attached a GDB so we can take a quick look at this. So we'll do Python 3 solve. It's taking a second. Very slow. There you go. If we look at the GOT right now, we should see everything looks pretty good. These are all libc addresses via map. And so if we do a, let's break on, right now we're at the scanf, so maybe let's break on an fwrite. We'll continue. So let's look at the GOT. So right now, again, exit is still in the current position. So we are currently right here. So if we exit out of this function, or if we finish this function, right before we call exit, we should be able to take a look at. And also, let's take a look at null. Oh, I need to finish first. Let's take a look at null first. We can see that the right pointer was overwritten so that it is now pointing at fwrite at GOT. So it already did the overwrite, but that means it is pointing right here. So that means it previously wrote something to right here. And so we were able to overwrite the exit handler in the GOT, and its exit is now instead pointing at our win function, and now the file pointer is here. So what happened in our attack was the file pointer was pointed here because we got to control the offset. It wrote out the value of win, overwriting the previous value of exit, and now the file pointer points here. So if we were to continue, next it's going to call exit in the C code. So we just did this one. It's going to call exit, but exit no longer calls exit, it calls win. So if we continue, we can see that dash has started and we now have shell. It doesn't work so well. There's no flag file, so it's going to exit, but if we run this remotely, we get flag, and that was the first challenge. Very cool to mess around in the file internals.